In this lecture, we'll continue truth tables. So we'll begin with a couple of examples of single sentences, and then we'll move on to what truth tables are actually intended for, which is testing the validity of a sequence. So as we finished the previous presentation, we had 3 different letters, and we saw that there are 8 different rows to account for all the possible combinations of trues and falses for each of the 3 letters. So we're probably going to stick to that here in the next few videos, because most of the truth tables that we'll do are going to be 3 letters long. Now there are some questions on the quizzes and exams that are just 2 letters, so they're a little bit shorter. But if you can master the 3-letter ones, then the 2-letter ones are not too bad comparative. So here, if we remember, what we've got is our key. So this is our key. This is given to us. We don't have to create it. It's just outlining all the possibilities of true and false that go with each of the individual propositions or letters here. So P, Q, and R. We see those somewhere here in this sentence. And so this is just our key that we're using to evaluate our actual sentence over here. And as we move forward, we got to remember that it is paramount that we recognize what the main operator is in the sentence that we are evaluating. So here, the sentence that we're evaluating is R or Q, arrow P. And we've got 2 different operators. We have the wedge and we have the arrow. And we have to ask ourselves which one is the main operator. Well, the main operator is the one that's outside the parentheses, which is going to be the arrow. So that's telling us that we have to do our wedge first. So what we're going to do is we're just going to drop down some dotted lines. And we're going to ignore this arrow and the P for a second. And we're just going to evaluate the R or Q to get the value for just the wedge. So here we're just going to ignore the P, just don't have to look at that part of the key. We're just looking at the R's and Q's. So where is a wedge true? Well, a wedge is true wherever one of the sides, at least one of the sides, are true. So got one true here, true, 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 and then the rest of them are false. So in all these instances in which I have a circle or have a true circled, we know that the value of this wedge statement is going to be true. And in these bottom 2 rows, it's going to be false, because both disjuncts, both the left side and the right side, left disjunct, right disjunct, they're both false. So that is the evaluation of just the wedge, but we're not interested in evaluating R or Q. We're interested in evaluating R or Q, arrow P. So let's erase all this stuff. And let's bring our arrow and our P back into the fold. And so here we have, this is our left side. Our P is going to be our right side, or our consequent. So we have to imagine that these values are over here. So this is my left side, or my antecedent. This is my right side, or my consequent. And so if you remember, an arrow is true wherever the left side or the antecedent is false, or the right side is true. And so we can just fill in the values here for the arrow by looking across. So left side, or sorry, the right side is true here in row 1, right side is true here in row 3, row 5, row 7, and then in row 7 and 8, the left side is false, so it also gets true. So remember, don't be confused just because this appears on the left side of the table and this one appears or looks like it appears on the right side of the table, that this is your left side and this is your right side. Reality is that your arrow is what you're evaluating here in the middle. So the R or P is on the left side. Your P, or sorry, R or Q is on the left side, and your P is on the right side. So you have to make sure. Sometimes it might be better to just transcribe all those values for P over here on the right hand side, such that you could write true, false, true, false, true, false, true, false. You don't have to. It's a little bit of extra work, but then you can see that these are your right side and the yellow is your left side. But that's how we're determining the arrow. And we gotta make sure for the arrow that we know which sides are left side and which sides are right side. But everywhere else, we have a true antecedent and a false consequent. So those ones are false. Now, we can erase all this stuff. And again, if you remember from the previous lecture, we're not interested in all of these columns. We're only interested in the one that evaluates the main operator. So we can get rid of all of this. When you go to do your quizzes in your exam, the only one that we're interested in is this main operator here on the far right side. And so this evaluates the actual sentence in its totality. Look at this next one, same thing as before. These three columns on the far left, P, Q, and R, just represent our key. They're just telling us the different values associated with the combinations. These are all possible combinations. And so these are given to you. You don't have to determine them in any way. They're just there. Now, if we look at our conclusion, or not our conclusion, but our sentence that we're evaluating here, it is tilde P, ampersand, Q, double arrow, R. And so we've got three different operators here, tilde, ampersand, and the biconditional. So we got to determine what's the main operator. Here again, you might be able to recognize, well, these parentheses are offsetting this, so there's one. Well, the ampersand has to be attached to two different things, so if that's the right side, this has to be the left side. So the main operator here is the ampersand. And we'll have to do the tilde and the biconditional before we can do the ampersand. So doing these one at a time, I'm just gonna block out all this, drop some dotted lines. So for tilde P, all we're going to do is we're going to take these values here and we're going to flip them over. So a T turns into an F and an F turns into a T. Simple as that. So all these values just get flipped into their opposite. Now, what we can do, or what we need to do, is the biconditional, the double arrow. So we'll just ignore that side of the ampersand now, and we'll just focus on Q double arrow R. And if you remember, for the biconditional is true wherever both sides are true, or both sides are false. But if they don't match, if they are false and true, or true and false, which are the cases here, then it is false. So wherever they match, it's true. Wherever they don't match, it's false. So now we can erase these. And now we're going to evaluate the ampersand using this as our left conjunct. This is our right conjunct. And so Where's an ampersand true? Well, it's true wherever both sides, both conjuncts are true. So both of them are true here, and both of them are true here. So we'll put a T in there. We'll put a T in here, and the rest of them have at least one of them false. So false, 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 and false. So now that we've determined the ampersand, this column here, we can get rid of these other columns because we don't need them anymore. We only needed them to determine the ampersand's value. And so this column here represents the evaluation of the full sentence tilde P and Q double arrow R. Finally, we'll do this last practice one, and then we'll actually move on to what truth tables are built for, which is determining if a logical argument is valid or invalid. But one more practice wouldn't hurt. So here we've got P and Q, or R arrow P. And so we've got three different operators again. We got an ampersand, we've got a wedge, we've got an arrow. Here it's pretty plain to see that you've got two different sides, each one bracketed off with a set of parentheses. So we'll have to do the ampersand and the arrow before we can do the main operator, which is the wedge. So let's just do one of them at a time. We'll do P and Q first. So P and Q, we'll ignore R for the time being. So where is an ampersand true? Well, an ampersand is true wherever both sides are true. Those would be the only two instances. The other ones have at least one of them false. So that's the ampersand. Get rid of that. Now we can focus on the conditional statement, or the arrow. We'll just ignore the rest of that. We're focusing on R arrow P. Remember that this R is our left side, or our antecedent, and the P in this case is our right side, or our consequent. So even though the R on the table is on the right hand side of the key and the P is on the left hand side, we gotta make sure that we pay attention to how it's written in the actual sentence. R comes before the P in the arrow, so R is our left side, or our antecedent, and P is our right side, or our consequent. And if you remember, for an arrow is true wherever the left side is false, or wherever the right side is true. So here in this row will be true, third row will be true, and then from the fifth row down, they'll all be true. The only ones that are false are here. And remember that the arrow is only false where you have a true antecedent and a false consequent. That's the same situation here. And so that's the evaluation for the arrow. Now we can erase all this stuff and then look at the wedge statement. So for the wedge statement, we're going to use this value here as our left side. We're going to use this value here as our right side. And where's a wedge true? Well, it's true wherever you have at least one side true. True, 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 true. So this one's going to be true. This one's going to be true, 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 true. The other one's false are these two right there, because both sides are false. And then all we got to do is eliminate this extra work that we had to do to get to this column here. And so that becomes the values for the full sentence P and Q or R arrow P. If you remember from the previous lecture, I went through the introduction to truth tables and I gave you some bullet points. We're going to do the same slide here again, but I want to just emphasize how we determine validity using truth tables. So if you remember, say truth tables are a way to check the logical structure of an argument. Each operator has a specific truth value based on the truth value associated with each of the propositions. That's what we've been doing. And then truth tables can contain any number of sentences, each premise, and the conclusion must appear somewhere in the truth table, which we'll start seeing here now that we're doing more than one sentence at a time. And so here becomes the more important part, which is how do we know when something is valid versus when something is invalid. So an argument is valid where all the premises are true and the conclusion is also true. It's invalid as long as you have one instance in which all the premises are true and the conclusion is false. It only takes one to make it invalid. But as you can see here, the thing that we're going to be most concentrated on when we're evaluating the validity of an argument within our truth table are the rows where all the premises are true. All we care about in the truth table are the instances in which all the premises are true. If there's a row in which the premises are not all true, we can just disregard it. It's not going to give us any information whatsoever. So when we're evaluating validity, we start from a position saying this argument is valid and it can only be invalidated by showing that there is an instance in which all the premises are true and the conclusion is false. It's automatically valid, but it can be invalidated if you can find an instance in which all the premises are true and the conclusion is false. That's the emphasis here. And if it's invalid, it requires a counterexample, which we'll go through as we do the practice problems from here on out. So this up here represents a logical argument. The little weird sign here in the middle offsets the premises from the conclusion. It just means therefore. So whenever you see this, it just means therefore. So arguments are composed of at least two different types of things. One of them is going to be premises. And premises appear on the left side of that therefore sign. So in this situation, we have two premises. You can have an infinite number of premises. I guess I should say you can have a very large number of premises. You would probably always have at least some definite amount of them, but there is no limit to the amount of premises that you can have in an argument. But when it comes to a conclusion, you can only have one, and that appears here on the right side of the therefore sign. So whenever you see an argument, or what we'll call a sequent, it's a sequent, meaning you have premises and then a conclusion. So you'll only ever have one conclusion. You can have from one, actually you can have zero premises at one point. But we don't do that here in this class. But you always have at least one premise, and there is no set number, but the commas offset the different premises. So if you look at our table here, we have a column for each different sentence. We have P and Q here. We have R or P here. And we have tilde R here. So whenever we're doing a truth table to determine whether or not an argument is valid or invalid, we have to have each of the premises somewhere in the truth table along with the conclusion. You have to determine the values of the premises and the conclusion. That's the important thing here. So the idea is that we do each of these one at a time, and these are pretty simple. They're only one operator. So looking at this P and Q, so we're going to ignore the R here for a moment. We're just going to focus on P and Q. P and Q is true wherever both of them are true. Both of them are true here, and both of them are true here. So true, true. The rest of these are going to be false. And that's it for that premise. So I can eliminate that, bring R back in, and we're done with P and Q. Now if we're looking at R or P, so R or P, we can ignore the Q for the moment. So what makes a disjunction or a wedge true? Well, it's as long as one of the sides are true. And so now we can see that's going to be true here, 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 and here. Only in rows 6 and 8, it's going to be false because you have two falses. You have false here and falses here. And so that one's done. Now we just have to evaluate the tilde R, which is we can ignore these. We're just going to take these values and we're going to flip them across. So T's will turn into F's, and F's will turn into T's. And so now, again, it's important to be able to identify what's what here. So these two columns are our premises, and if you remember our definition for validity on the previous slide, it says that an argument is valid where all the premises are true and the consequent is also true. And again, it can only be invalidated. We can only find an instance in which all the premises are true and the conclusion is false, and that would make it invalid. But what we do with truth tables when we're trying to determine validity is just begin by looking for the situations in which the premises are all true. So we've got two premises, so they're both true there. They're both true there. And in every other situation, at least one of them is false. You know, this left one is false, this left one is false, left one is false. Both of them are false. Left one's false. Both of them are false. So we can just ignore rows 2, 3, 4, 6, 7, and 8. They don't matter to us anymore. You'll still have to put the values in for each of the different premises in the conclusion, but these rows don't mean anything to us. We're just going to ignore them at this stage. We're just testing for validity now. And so we can just act like these rows don't even exist. So if you remember the definition for validity, it says it's valid as long as there's no instance in which all the premises are true and the conclusion is false. Well, if we look here in this first row, our conclusion is false. We have true premises and a false conclusion. That means this has to be invalid. And you might say, well, how come it's got to be invalid? Because we've got another instance down here in which the premises are true and the conclusion's true. How do we know it's invalid? Well, we know it's invalid because it only takes one instance in which you have all true premises and a false conclusion to make it invalid. So even if all these rows, the premises were true and the conclusion was true, you could have, 7 rows in which the premises are all true and the conclusion is also true, but all it takes is one instance in which the premises are all true, the conclusion is false to make it invalid. And so that's what we have here in this first row. And so that's what makes it invalid. Now a counterexample is pretty easy. What we're going to do is we're going to recognize what row the premises are all true and the conclusion is false, which is here in row 1. And we're just going to copy the values that we have here for P, Q, and R. So what we'll do is we'll write P equals T, Q equals T, R equals T. And that's just identifying that there is a row, in fact, this first row, in which the premises end up being true and the conclusion ends up being false, and that's how you know it's invalid. There'll be instances in which you will see that there are multiple rows that could invalidate an argument, and all we'll need is one counterexample. You don't need to list every possible counterexample, you just need to list one. And so here, this is one of the, this is the only option for a counterexample that shows that the argument is invalid. Moving on to this next one. So again, we have two premises. We have P arrow Q, we have P and R, and then we have our one conclusion. Always just have one conclusion, which goes here. Now, just like before, these are pretty simple, at least the premises are. They're just a single operator, so we can just do them one at a time. So P arrow Q, well, where's that statement true? Well, it's true wherever the left side is false or the right side is true. And so we have true, 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 and true. Only here in rows 3 and 7 do we have a false left, or sorry, a true antecedent and a false consequent there and there. So that's the first premise. Now looking at this next one, P and R. It's an ampersand, so it's going to be true wherever both sides are true. So here they're both true, and here they're both true. All the other ones, they're at least one of them is false, so we got true, false, true, false, 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 false. And now we just have to do the conclusion. Now, in our conclusion though, it's Q or tilde R. We have two different operators here. We got to determine which one the main operator is. And so here, we can see that the tilde just goes with the R, so our main operator is the wedge, which means we'll have to do the wedge second, have to do the tilde R first, so let's just drop down some lines. So ignoring the wedge for a second, just focusing on the tilde R, right? Ignore those. So the T's will turn into F's, and the F's will turn into T's. And then we can do the wedge, so this is our right side. The Q is our left side. So where's a wedge true? Well, it's true wherever you have at least one side true. And so you have T's in 1 and 2, and then 5 through 8. So only 3 and 4 get falses. So we can erase all this. And remember, now that we've got our main operator, the wedge, we can erase all this because it's only going to confuse us now that we're going to do validity, which is why we sort of do that the whole time. It's because you don't want too many lines obscuring what you got to do. Because when we're testing for validity, we're only testing the main operators and the premises and the conclusion. So that's why we sort of erase all of them at the very end and only focus on the main operator. So, just like last time, we're going to highlight where we have true premises. So they're both true here, and doesn't look like anywhere else. So you have at least one false Everywhere else, you get one of them false, one of them false, false, one of them false. So we're just going to ignore all of these because the premises are not all true. We only care about where all the premises are true. And in this one situation in which they are all true, we have a true conclusion. And so this situation is valid because in every instance in which all the premises are true, the conclusion is also true. And because it's valid, there is no counterexample. Counterexamples only apply to invalid arguments. So that's all you have to do for this one. Moving on to the next one here. So again, we've got two different premises. We've got R double arrow Q. We have R and tilde P. And we have tilde P or Q. And so what we'll do is we'll just do each of the premises one at a time. So remember, for a double arrow, we're going to ignore the P here because we're just dealing with R double arrow Q. A double arrow is true wherever both sides are true or both sides are false. If they match, it's true. If they don't match, it's false. That's the easiest way to remember a double arrow. So in all these other instances, they are false. That's all we have to do for that one. Now, if we look at the second premise, we have R and tilde P. So we've got two operators. The tilde is just over the P, so we'll have to do that one first. So ignoring this ampersand for a moment, ignoring both of these columns because we don't need them. We're just focusing on the P. Right now, we're going to take the values here and we're just going to flip them over. So T's will turn into F's. And F's will turn into T's. So what we're doing is we're just looking at all these and they get flipped over. A T turns into an F and an F turns into a T. And the same thing just happens all the way down. So now that we've done that, we can reintroduce the ampersand and we'll get rid of that stuff. So now the ampersand, we're focusing on just the R in our key and the tilde P that we just wrote down. So this is our left side, this is our right side. So where's an ampersand true? Well, it's true wherever both of them are true. That happens here and here, and looks like nowhere else. So the rest of them are going to be false. And now we can erase all this. Remember, we don't need this column because we're only interested in the main operator, which is the ampersand. So we just have to do our conclusion. Our conclusion also has two operators in it. Now, this one might look a little bit tricky, but remember that the tilde is only associated with the P because there aren't parentheses. So in this instance, our wedge is the main operator still. If it were written like this, then the tilde would be our main operator, but it's not written like that. Instead, it's written such that it only applies to the tilde P. So we got to do the tilde first, and then we can do the wedge second. So we're going to ignore the Q. We're just going to focus on the P. So ignore those. So just like with the other tilde, we're just going to flip the values of P from T's to F's and F's to T's. Like that. And we can bring the wedge Q back in, and so this will be our left side, RQ will be our right side. So where is a wedge true? Well, it's true wherever one of the sides are true. So that's going to be true, true, false, true, 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 false, true. And again, we can just erase this column because we don't need it anymore. We can erase all this. And so now we're at the step in which we're determining the validity of this argument. And so we're just going to look for instances in which we have all true premises. We have one instance here. And again, that looks like to be the only one that we've got. And so we can just ignore this, 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 and this. So we're only interested in the rows in which the premises are all true. These are our premises. Get rid of that for a second. So those are our premises. Remembering that the premises appear on the left side of the therefore sign. And what's our conclusion? Well, our conclusion is true. So in this situation, it is valid because the only instance in which you have all true premises, the conclusion is also true. And for a counterexample, there isn't one because it is a valid argument. Again, we got two premises here. I guess I should do different colors. So there's one, there's the other. Those are our premises. Here is our conclusion. So again, these are sort of simple. They're just one operator for the premises. So what we're going to do is we'll just do the RAROP first. We'll ignore this one. Again, I got to emphasize this one is the arrow, so you have to make sure that you focus on which side's the left side and which side's the right side. In this situation, the R is our left side or our antecedent right there, and our P is our right side or our consequent right there. So what matters is how it's written in the premise column. Doesn't matter how it's written in the key, it matters how it's written in the premise column. If you do it backwards, the values are going to be off. So make sure you've always got it right, such that you're doing what's on the left side, what's on the right side, at least for the arrow, because that's where it counts. So remember that an arrow is true wherever the left side is false, or the right side is true. And so here it's going to be true, 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 true. So in rows 2 and 4, it's going to be false because you have a true antecedent and a false consequent. Now, oops, that one's done. So we can move on to the next premise. The next premise is Q and P. So we can ignore the R here. So Q and P, they're true wherever they're both true. So that's going to be here and here. True and true, and the rest of them are false because at least one of them are false in the other rows. Just like that. And bring that back, and now we just have to do our conclusion. Here, our main operator is the ampersand, because we can tell that because our arrow is in our parentheses set there. So that tells us we need to do the arrow first. And then we can do the ampersand. So let's ignore the Q and for a second, and then we'll just focus on the P and R. So let's ignore those. So again, with an arrow, it's true wherever the left side is false, or the right side is true. In this situation, the R is our right side or our consequent, and the P is our left side or our antecedent. So the key does read left to right. So that works in our favor. Just doesn't always work that way. So in these instances, they are true. Only in lines 6 and 5 and 7 they'll be false. Like that. So now that we've done the conditional statement, we can bring the Q and back in. Well, get rid of this. So we're not going to pay any attention to the P and R now. All we care about is the Q as our left side, and then also our P arrow R as our right side. And the main operator here is an ampersand, so we're just looking for instances in which they are both true, true and true, true and true, true and true. So we have true here, false, 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 true, false, and false. And so that becomes the value of the whole conclusion. That's the one that we'll end up needing, when we start looking at validity. So again, next step is to look for instances in which all the premises are true. Which one's there? One is there. And it looks like all the other ones have at least one false premise, so we can ignore this row, this row, this row, this row, this row, this row. Again, we're only looking for instances in which both the premises or all of the premises are true, which these are our premises, and you can see that in all the ones that I just put a line through, at least one of those is false down that column. The only ones are 1 and 5 in which they're both true. And here we've got another situation in which the first row looks like it's valid, but we do have a counterexample or an instance in which all the premises are true and the conclusion is false here in line 5. So this one is going to be invalid. And to construct our counterexample, we're just going to look at that row and copy these values here. So we're going to put P, Q, R, and then P is T, Q is T, R is F. And so that becomes our counterexample. It's just identifying where in the truth table is the instance in which all the premises are true and the conclusion is false. And that's all you have to do for that once you get to the invalid. Finding the counterexample is not bad because all you got to do is just look at your key, this, and just copy the values that are in that row for each of those letters. On to this next one. Again, we've got two premises. Should do them in different colors. And as always, we've only got one conclusion. And so we just want to do each one individually. So looking at this first premise, it's an arrow. An arrow is true wherever the left side is false or the right side is true. So it's going to be true, true, false, true, 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 false, true. Looking at the second one, we've got R or P, so we can just ignore the Q here. A wedge is true wherever you have at least one of the sides are true. And so you know it's true, 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 false, true, false. So here in row 6 and 8, they're both false. Those two premises are pretty easy, and actually our conclusion is pretty easy too. It is just Q arrow R, so we can ignore the P here. So just as we saw with P arrow Q, the idea for an arrow is that if the left side is false or the right side is true, then it is true. And so you have trues in all of these with the exception of 6 and 7, or sorry, 5 and 6. And those are true. So no multiple operators in this one. We got to remember, let's look at our premises. Where are our premises all true? Well, they are all true here, 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 and that looks like it. So we can ignore this row, this row, this row, and this row. Now we just gotta look, and we see, yeah, true, 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 and here is a false. So, as I've said before, even though you have more trues than you have falses for the conclusion, even though you have more instances in which all the premises are true and the conclusion is false, it only takes one to make it invalid. So this one example, or this one row, is enough to make it invalid. And just as we've done before, determining the counterexample is pretty easy. All we gotta do is look at the row in which it happens and look at our key. So our P is T, our Q is T, our R is F, and so that's our counterexample. So again, the whole point here is that you can have multiple instances in which all the premises are true and the conclusion is true, but as long as you have one instance in which all the premises are true and the conclusion is false, that's enough to make the whole argument invalid. Moving on to this next one, we've got two premises again, and our one conclusion. Just going one at a time here. So, first premise is tilde p. So all we're going to do is we're going to take all these values and we're just going to reverse them over here. So t's will turn into f's and f's into t's. Tildes are pretty easy. All you got to do is reverse whatever they are tilted on. That might be the way to say it. But so whatever the tilde is associated with, we just got to flip the values with them. If it is a complex sentence, then it's just the reverse of what is within the premise or within the parentheses. Or if it's just a single letter, just got to reverse the letters. So that's the first premise. Looking at the second premise, we have two operators. We have R and tilde Q. The tilde is just associated with the Q, so we'll have to do the tilde first, and then we'll finish with the ampersand. So just draw some dotted lines down here. Ignore the R and we can just ignore this stuff for right now. And so just like we did with the tilde P, we're just going to take all these values and we're going to flip them. T's turn into F's, F's turn into T's, and then we'll use those values and the R value. So we'll ignore those. So these are our left side, these are our right side. And ampersand is true where both of them are true. Those are both true, those are both true. And the rest of them look like they are false. And since we got the main operator there, we can get rid of these. So we don't need them anymore. We only care about the main operator, or at least the value associated with the main operator of the whole sentence. Now, we just gotta do the conclusion. Get rid of that. Just because here again, we've got our arrow P, Q, two different operators here. The one within the parentheses needs to get done first. And then the second one, which is our main operator, can get done second. So ignore the wedge Q for the moment because we just got to do the R arrow P. So again, don't fall into the trap. R is our antecedent, or our left side, and our P is our consequent, or our right side. And so what we're looking for are instances in which the left side, or the antecedent, is false, and the right side, or the right side is true. And so those are all going to be true, false, true, false, and then the rest of them are true. And so now we can add in the wedge. So this is our left side of the wedge. The Q is going to be our right side. So where's a wedge true? Well, it's true as long as one of them are true. So true, 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 true. So it can be true, 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 false, true, 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 true. So we can erase this left side because that's just associated with the arrow statement. We just need the main operator there. And so now we just got to do the same thing as we've done before. We just got to look for instances in which all the premises are true. So these first two columns, tilde P and R and tilde Q, are our premises. So let's see. This one, they're both false. One of them's false, one of them's false. Both of them are true. Both of them are false. One of them is false. Both of them are false. One of them is false. So we've only got one row in which we care about, which is this fourth row. And it so happens that our conclusion is false. So this one is also invalid. And we just got to provide a counterexample. Which are going to be these values here. P is false, Q is false, R is T. We just get those by copying these down here in the counterexample. So here again, just like with all the other ones, we've got two premises and a single conclusion, always one conclusion. And so let's just do each of these one at a time. Here, the R double arrow P. Remember that a biconditional double arrow is true wherever they both match. So they both match here, they both match here, they both match here, and they both match here. So it's going to be true. These rows, false in all the other ones. And then looking at the next one, we have two operators here. So we've got R or P and Q. We have to do the one that's inside the parentheses first because the wedge is our main operator. So focusing on the ampersand first, we'll just ignore that. So an ampersand is true wherever they are both true, which is there. Here in rows 1 and 5, the rest of them, one of them, oops, I screwed up there for a second. Remember that this is only one part of it, so I should drop down some dotted lines so I remember that this is just the right side of the sentence. The rest of these are falses. And now we can bring R or Q back in. These we can ignore because this is our left side, this is our right side. And then, so it's going to be wherever at least one of them is true, 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 true. So anywhere where you see a T, any row in which one of those, either the left side, the R, or the right side, the P and Q are true, true. The rest of them are false. And once we've got that, we can erase this right side because we only care about the main operator. And then we just got to do the conclusion. And so here again, we've got ampersand within the parentheses, so we know we got to do that one first. The wedge is going to be our main operator, so do the ampersand first. Ignore the wedge Q. So P and R, where are they both true? They're both true here, they're both true here, and the rest of them, they're all going to be false. So true, false, true, and the rest of them are false. And we're going to bring back the wedge Q. And so we can ignore these because this is our right side, this is our left side. So a wedge again is true wherever one of the sides are true, like that. So true, 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 false, true, true, false, false. And we don't need this column anymore. It's just the P and R, and we only care about the wedge because it's the main operator for the whole conclusion. And so now we just have to look for instances in which we have all true premises here, here, and that looks like it. All these other ones we can just forget about because at least one of the premises are false in those lines. And so here it's true, and here it's true. So since in every instance all the premises are true, in every instance in which all the premises are true, the conclusion is also true. That makes it valid. And because it's valid, you don't need a counterexample. this will be the last one for this presentation. So here again, we've got two premises. And as always, one conclusion. So let's just do them one at a time. So P arrow Q is our first premise. So again, an arrow is true wherever the left side is false or the right side is true. So true, true, false, true, 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 false, true. Oops. Make that one look a little bit better. All right, now we got that one. We can move on to the wedge, so P or R, so we can ignore the Q again. And so with this, remember that a wedge is true wherever at least one of the sides are true. So we know that they are true except for in 6 and 8. So those are our two premises. Now here we've got two operators. So within the parentheses, we've got an arrow, and outside the parentheses, we've got a tilde. And so if you remember, whenever the tilde is outside the full set of parentheses, it's governing everything else. So if you've got a tilde and then everything here on the right, that means the tilde is the main operator. So we'll have to do the arrow first, and then we'll do the tilde second. So let's just focus on the arrow. So the arrow is going to be just Q arrow R. So we can ignore the P for right now. I'm going to drop down some lines. So Q arrow R, so it's an arrow, so it's going to be true wherever the left side is false or the right side is true. So you're going to have true, 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 false, false, true, true. Now that we've got that, we can bring the tilde back in, and so you know with a tilde, all we gotta do is flip the values, so these t's will turn into f's, and these f's will, so these t's will turn into f's, and the f's will turn into t's. Can erase this over here because all we care about is the main operator. There. Now we just have to look for instances in which all the premises are true. Got one there. Got one there. There. Got one there. The rest of them have at least one of them that's false. Now, what you'll see here is that we have a couple instances in which we have false, a false conclusion and true premises. So you might say, well, what do we got to do here? Well, first things first is we already know it's invalid because there are instances in which you have true premises and a false conclusion. So ultimately, it's got to be invalid. Even though you have one instance in which you have a true conclusion and all true premises, that doesn't matter. You have that here. Remember, it only takes one to make it invalid. So in this situation, you have multiple instances in which you have all true premises and a false conclusion. What you'll do for a counterexample is you can list any one of these. So if you want, you can list all of them as true, or these these such that it's false, true, true. Or you can list these such that it is false, false, true. Any one of those works. You only need one counterexample when it's invalid. Now, when it comes to the quizzes and exams, if there are multiple counterexamples, there might be a multiple choice answer. Only one of those will be of the possible counterexamples there. But say if you were to do a truth table without, having to take a quiz or an exam, any one of those equally count as a counterexample. You don't need to list every single counterexample when something's invalid. You only need to list one because one suffices to say that the argument itself is invalid. So that concludes this lecture. In the next lectures, we'll just keep doing some more practice truth tables. So until then, see ya.